So first step is to make sure that you are connecting the circuit in proper order. So always try to connect the positive of the circuit with the as shown in the circuit diagram. Remember that the ampere will be connected, positive side of the ampere will be connected with the positive end of the battery, and when you are connecting the galvanometer, the order should be reversed. So the positive end of the galvanometer will be connected to the negative end of the ammeter, and negative end of the galvanometer will be connected to the positive end of the galvanometer. So this is you have to make sure. Before constructing the circuit, once your circuit is constructed, you have to make sure that your key is open. So this is the key, as you can see, the key is open now, and once you are switching on the circuit, make sure your key is open. Now once your key is closed, you will see that there is a deflection in the circuit. So ammeter and voltmeter both are showing some deflection. Now you have to change the current and take recordings. Now this recording can change based on your college experiment setup available. Now you have to make sure that for first experiment, that is resistance per unit length, you have to take 3 different readings. Now how can you take 3 different readings? For example, in this setup I am taking readings for 100 milliampere. You have to change the current and correspondingly you have to note the voltage. You should not change the voltage, you have to change the current and measure the respective voltage. Now when you are taking the current, say 100 milliampere, here I am getting the current around voltage around so remember that in this voltmeter also we have 0 to 0.5 then 1. So basically between 0 to 1 I have 20 divisions, right. So each division is basically 0.05 volt. So each division here is 0.05 volt. So what you have to be careful about, so 0.05 multiplied by the number of division you can see. So 1, 2, 3, 4, 5, almost 5. So it will be 0.25 volt. So your reading will be 0.25 volt for 100 milliampere, right. So take that measurement and then you proceed to the next current, which is 200 milliampere. Slowly change the current to 200, and once you have reached the 200 milliampere, you will see that the voltmeter also have moved. So now you see that the voltmeter is now moved to around 5, 6, 7, almost at 7, between 7 and 8, and do not, if the reading is coming between two scales, try to take the closest possible value. So here it is almost at 8. So I am taking 8 means 0.4 volt. So 0.4 volt will be the reading for the second part. Now again you change the current to around 300 milliampere. Now after 300 milliampere the sensitivity increases, so you should keep it where it is steady. So when the reading is at 300 volt, 300 milliampere, you are getting around 0.55 volt. So take these readings, and once your reading is done, you have to calculate it from the table and average, taking the average and calculate the resistance, and then you have to divide the resistance with the given length. The length of the wire will be provided to you, the diameter of the wire will also be provided to you. Now make sure that when you are taking the reading, you have to look directly, not from sides, otherwise there will be an parallax error. So try to avoid it, look directly from the top as much as possible so that your reading is perfect. Now, so once your calculation is done, you have to show the calculations as well, and because the first experiment you do not need to draw any graph, so you can record 3 different values and calculate the mean resistance from each calculation, and don't forget to sign your recordings through the invigilator. At least one of the readings should be signed by the invigilator. So now we are doing the second experiment, which is resistivity of our wire. Now in this experiment, it is a graph based experiment, so you have to take minimum 5 readings. So make sure that you are taking the readings such a way that your 5 readings are completed and you are plotting the graph properly. Now, in this experiment what we are supposed to do, first of all, again the circuit is same as your first experiment, where you have to connect all the positives with the positives. In case of voltmeter it will be opposite, that is positive end of the ammeter with the negative end of the galvanometer, and negative end of the ammeter with the positive end of the voltmeter. So, now before starting your experiment you have to make sure that your circuit is off, your key is open. Now, you connect the circuit using the key. Now, as you can see that you have to change the rheostat to make sure that you are getting 5 minimum readings. Now, you have to check, do not go very far, because around the edge of the rheostat the reading fluctuates too much. So, you have to adjust your reading such a way that you are able to get 5 readings. Now, in this particular setup we are taking readings for 50 milliampere, and you are changing the current and measuring the corresponding voltage. Very important, do not change the voltage to measure the current, you have to change the current and measure the corresponding voltage. So, 50 milliampere, then 100 milliampere, then 150 milliampere, 200 milliampere, 250 and 300. This way you can get the 5 readings required. Now, based on your laboratory equipment that you are using, the values will change. So, do not copy the value that we are showing in this particular experiment. You have to record the experiment in front of the invigilator. So, do not make that mistake. Also, one more important tip. So, when connecting the circuit you have to make sure that you are connecting the conducting part of the metallic wire with the positive and negative of the corresponding voltmeter ammeter. Also, the wire should be connected with the battery. Do not connect the insulating part. Okay, this red part as you can see is an insulating part. Do not connect this insulating part when you are constructing the circuit. So, this is a very important precaution. If you are doing something wrong, maybe you are getting a voltmeter reading in the opposite direction, ammeter reading in the opposite direction. So, make sure you are changing, and if you want to change one equipment at a time. Do not change everything, and make sure your circuit is perfect before switching on the circuit or switching on the key. Right. So, all the best for these 2 experiments. If you are getting these 2 experiments, then you should be able to get full 30 out of 30. Now, let us do the third experiment. It is figure of merit of a galvanometer, very tricky experiment, and many students falter on how to perform the experiment. So, here is the circuit. Here there will be a battery provided to you. Now, it can be a static battery, it can be a variable battery like this. So, here as you can see the voltage can be varied. There are once you have constructed the circuit diagram, again the rule is same. Positive has to be connected with positive, negative has to be connected with this negative, and resistance boxes you can connect any order, does not matter, because they do not have any polarity, but the galvanometer do have a polarity. So, the positive end of the supply should be connected to the positive of the galvanometer, and negative end of the supply should be connected to the negative end of the galvanometer via resistance box. Okay. Now, here are 2 keys, one key will be closed for the first part, and another key will be we will open this key for the first experiment, and then we will put the first key, we will put in the first key. Now, remember, if you do not have any resistance, the circuit may go to overdrive. So, have some 150 resistances removed, so that your circuit remains safe. Now, once you have put in the key back into the place, you will see that the resistance is moving very far. So, keep some resistance, high resistance removed. So, now, so as you can see, when you have removed some resistance, you are getting a deflection in the circuit. So, let us say we will start with, you have to take minimum 3 different readings for this. Again, this is a calculation based experiment. So, you need at least 3 readings. Now, once you have removed some high value resistances, you will get some deflection in the galvanometer. Now, for this experiment, you have to use the second resistance box as well. So, remember to keep even value, so that once you are doing the second part of the experiment, you are getting a decent value. If you are doing some uneven value, so for example, 9 or 11, your experiment may be fail. So, that is why I request you to try to keep it around 10 for the first reading. So, we are keeping it around 10. And once you are sure that okay, I have achieved what I was looking for, then you have to put in the second key back, keeping the first key closed. Now, you remove the resistances and try to get a half deflection. Half deflection in the sense, first we got 10 deflection. So, now you have to adjust the resistance so that you get a deflection of 5. Okay. Okay, so as you can see, we are almost getting the half of the previous deflection. So, this resistance, these two resistances are important. Now, in the resistance box, resistances are given in the ratio of 5:2:2:1, right. The reason obviously I hope you are aware of, so that you can get any combination of resistances. So, as you can see from the top, we are having 10,000 and 5,000. So, 15,000 resistance in this resistance box, and here we have 100 ohm resistance. Okay. So, from this you can calculate the figure of merit of the galvanometer. Now, you have to repeat the experiment with a different set of resistances, so that you can change the deflection. First, obviously, you have to remove this key, and then you have to adjust the resistances so that you get a deflection which is slightly more than, for example, now you will start with doing with 20. So, here we have 20 ohm. 20 deflection. So, deflection is important. Now, again you have to put back the second key and try to adjust the resistance such that you get the half deflection. So, half deflection method, this is why it is called half deflection method. So, once you get the half deflection, okay, perfect. So, this is how you can perform the experiment for 3 times, and you have to calculate the average figure of merit from each of the observations. Now, we are going to do one of the most trickiest and difficult experiment, which we are going to measure the refractive index of a glass slab. Now, in this experiment, what we require a travelling microscope, and also we require a piece of paper where you have cross mark ink. Now, you have to focus this ink first case through air and second case using the glass slab. So, this is very simple process, theory wise very simple, but practically it is one of the most difficult experiment. Now, I am going to give you one small trick that you can use, because if you are using a cross mark like this, it is very difficult for you to focus. Now, what you can do, you can use a paper like this where you have scribbling like this. This actually help you to focus much better when you place it under the microscope. So, instead of focusing only on a single point, you can focus on multiple lines like this. So, this is a trick and hack that I am going to share with you. Now, another difficult part is the least count you can calculate at 0 position, but the CVD of the measurement, right. So, where your vernier scale is actually coinciding with main scale, that is something very tricky, but if you perform it properly, if you try to find it properly, there will be a small equipment like this, or you will be given a convex lens to find the exact location where it is overlapping. Try to find that point, and once you have done, you can use the very simple formula to adjust it. So, what are the steps? First step is to focus the piece of paper using the travelling microscope, and if you are wearing a spec like me, you have to remove your spec so that you get the perfect focus. So, once it is focused using this in air, then adjust your microscope so that you get the perfect balance. Now, once your focus is clear, make sure you have enough light falling on this paper. Now, second stage is to put a glass slab on top of this and refocus this system again, and once you have focused this again, corresponding reading should be taken. So, first reading is the reading only in air, second is the reading when you have put on the glass slab, and third reading is when you put some chalk dust on top of this glass slab and focus again. Now, here you have to focus only on the chalk dust and take the measurement again. So, now all these 3 readings are done, you can take the you can measure the refractive index of the glass slab. Now, remember that if you are manipulating the data or cheating, if you are getting exact 1.5, then teacher might ask you, show me the exact method. So, do not do that. If in case you are getting 1.49 or 1.51, that is more acceptable than exact 1.5 of a glass, right. All the best for your experiment if you are getting this experiment. Now let us do one more tricky experiment, that is the conversion of galvanometer into a voltmeter. In this experiment, the galvanometer resistance G and the galvanometer constant K will be provided to you, and based on that you have to calculate the required resistance and already set up the resistance in this circuit before you put on the key. Now once you put on the key, you have to check that for each value of the voltage, whether your galvanometer reading and voltage reading are matching or not. It is very, very important to get a 0 error. 0.1 error is still okay, but if it is more than 0.1, marks can be deducted. So make sure that your error value is very, very less. And how to calculate the error? So for example, my galvanometer is showing a reading of 15 and my voltmeter is showing a reading of 1.5. That means it's a 0 error. But in case you are getting say a reading of 20, but your voltmeter is showing a reading of 1.5, that is considered to be a huge error and marks will be deducted for your calculations, right. Remember, it is a calculation based experiment. So again you have to take 3 trials. So make sure you take all the 3 trials and calculate the value of error in each and every steps. Now in many cases you do not need to make it a table form. So some externals do prefer to prepare your table. So practice the table as well in case you are supposed to do that. Otherwise only the average value is sufficient. So once the circuit is complete, put on the key, check the reading of the voltmeter and the galvanometer. Make sure that you are removing the resistance from the resistance box exactly equals to the resistance of the galvanometer, and your readings of the voltmeter and the galvanometer should be corresponding to each other. For example, as I mentioned, if it is 1.5 in the voltmeter, you are supposed to get 15 deflection in galvanometer, right. And the circuit diagram, you can follow your manual for how to construct the circuit. Obviously, I hope you have practiced the circuit. Now remember, in this circuit is a slightly tricky circuit where you have to connect 3 wires along in the positive of the battery, and 1 wire comes to the rheostat, 1 wire comes to the resistance box, 1 wire comes to the voltmeter. So make sure you are connecting the resistances, connecting the components properly. Now once your experiment is done, don't forget to remove the key of the circuit. Now let us do one of the most easiest experiment, that is PN junction, forward bias of the PN junction diode. Now when a diode is given to you, remember the black side of the diode is positive, the gray side is negative. So when you are biasing a diode, it is very, very essential that you are biasing it properly. So the positive side of the diode should be connected to the positive of the battery and negative side should be connected to the negative side of the battery. So that forward biasing means we are obviously doing the current is being passed to the diode. Now here we are using a silicon diode. So for a silicon diode, the cutoff voltage is expected to be 0.7 volt. Generally most of the colleges use silicon diode because germanium diode have a very low cutoff voltage. So silicon diode has a 0.7 volt cutoff voltage. Now when you have constructed the circuit according to the circuit diagram, make sure your circuit is switched off. Now when you switching on the circuit and slowly increase the voltage, remember you are changing the voltage in this case, and as you are changing the voltage, you see that the ammeter showing 0 movement. That means even if the voltage is there, current is not flowing in the circuit. So when you are slowly increasing the voltage up to 0.5 volt, still the current in the circuit is 0. Now as soon as you cross the 0.7 threshold, the current starts to increase in the circuit. Now that means from here onwards you have to be very, very careful, and also remember that you have to take at least 5 different measurements to plot the forward bias graph. So afterwards, after this 0.7, your voltage will change slowly, but the current will change very, very rapidly. So make sure you are able to take at least 5 different readings, right. And once you are done with the readings, you have to plot the V versus I graph in a graph paper, neat and clean. And obviously if you are getting this experiment, you should be consider yourself lucky. This is one of the most easiest experiment, and all the best for your practical exam. Okay, now let us discuss another important experiment where we are going to determine the frequency of an AC. Now here we are using a system of electromagnet which vibrates on the when a AC current passes through it. Now when you switch on the circuit, you will see that there is a small, very little vibration. Now you have to adjust the length of this bridges and adjust it for the primary resonance. As you can see here, the sound is the maximum. Let's hear the sound. If you move it from this point, the sound is completely gone. That means the resonance is disturbed. So you have to adjust the bridges and find the exact point where this maximum vibration happens. You can use a piece of paper, and at the point of resonance the piece of paper will fall. Now next step is you have to take 5 different results, because it again it's a graph based experiment, so you have to take 5 different record. For that you have to, initially we are using 500 gram, now you have to change it to another 500 gram, that is 1 kg, next 1.5 kg, then 2 kgs, and lastly you have to add another last 500 gram to get 2.5 kg. So once you get all the 2.5 kg, the resonance frequency will, the resonance length will change, and based on that resonance length you have to plot a graph of L square versus T. Gravitational constant G will be given, the mass per unit length of the wire will be given, and then you have to calculate the frequency. Normally the frequency of an AC is about 50 Hz. You should get the exact 50 Hz if you do the experiment perfectly. Now let us move on to the one more important and slightly tricky experiment, where we have to find the focal length of a convex lens. Now in this experiment the rough estimate of the focal length is compulsory, do not skip that. And in this part what you have to do, you have to take a stand and a white screen like this, and adjust the lens such that you get a clear focused image of a distant building that you can see from your window of your college or a very distant point which is located outside. Now once you have done it, use a scale and measure the distance between these 2 points. Remember, when measuring the distance you are trying to measure the distance from the screen and to the middle of the lens. So that is very, very important. Do not take the middle of this screen. You have to start measuring from this surface and till the middle of this frame. Now when you are measuring rough estimate, you should align the scale and take a measurement which is coming out to be around 10 centimeter in this case. Now use this value when you are performing the experiment using the optical bench. So now once you are done with the rough experiment, try to find the focal length from the 2F positions. For example, in our rough experiment measurement we got a rough estimated focal length to be 10 centimeter. So we will start with 20 centimeter. So 20 centimeter will be our object pin, and we will fix our image pin also around 20 centimeter. That is a back method. Obviously I am teaching you how to trick. So first measurement should be around 20 centimeter, right? 20 centimeter from the lens, 20 centimeter from the lens in this side as well. So because we know if the distance is 2f, you get exactly image formed at 2f. Now if this is object pin, how to observe the image? Very, very interesting. So when you observe from this side of the lens, you will see an image forming exactly on top of this. Now align your image pin so that the height should be same, also the alignment of the pins should also be same. Now once you get the image on top of this like this, you have to make sure there is no parallax. Now, how to remove the parallax or how to know that there is a parallax? So, parallax is when you move your head like this, when you move your head by closing one eye, and if the image pin and object pin both are moving together. So, if they are stick together like this, then we will say there is no parallax, but if one pin is moving on the other side, another pin is moving on the opposite side, then there is a parallax. Now, based on where your image pin is, suppose it is here or here, so you will get a different parallax and you have to adjust it so that you get exactly perfect zero parallax. Now, zero parallax is easy for the first reading, that is 2f. Now, you have to adjust the distance slightly, you have to decrease it, but remember that you should not go below the rough estimated focal length. Suppose your rough estimated focal length is 15 and you are starting with 30 centimeter, you can go higher than 30 centimeter, but it should not go below 15 centimeter, otherwise you will not get a real image, you will get a virtual image, right. In this experiment you have to take 5 different measurements, because it is a plotting graph experiment, you have to plot u versus v. So, to plot the graph you have to take 5 different u's and corresponding 5 different v's. Now, if you know the rough estimated value of focal length, which is around 10 centimeter in this case, you can back calculate and find the u's for different v's and almost try to adjust it, but remember that you have to sign the readings with the invigilator. At least one of the readings should be signed by the invigilator. Make sure you are signing up the 2f, which is very easy to find, right. And with these tips and tricks, all the best for your upcoming practical exam. I will be back with more experiment. Now, let us do one more tricky experiment, that is refractive index of water. In this method you can use two different, this is basically two different experiment. One is using mirror and lens. So, you will be given a convex lens and a plane mirror like this. So, once you are doing the experiment, you put the plane mirror first, then you put the convex lens on top of it and measure the height of this exact point of no parallax. Again, at the point of no parallax, there will be appearing one more pin over here. You will see the image pin coming over here, and at the point of no parallax, when you move your head, both pins should move parallelly without any gap between them. Now, second stage is very tricky. At this stage, what you have to do, you have to put some water on this glass mirror, and you have to put back the lens again. Now, this is a combination of a concave lens and a convex lens. Now, concave lens is basically the liquid surface, and on top of this there is a convex lens. So, this is basically acting like a combination of lenses. Now, the focal length should increase and you have to adjust it again, pick it up, and then from the measurement of the radius of curvature of the liquid, you can calculate the exact refractive index of water. Now, this experiment can be also performed using a completely different equipment, that is a concave mirror. Now, remember that even though they are considered to be two different experiments, the method is exactly same. The first step is to focus using the concave lens, and once you have achieved the focus, again you have to add some water on top of the concave lens. Now, again it is basically a concave lens, sorry, not concave lens, concave mirror, and on top of the concave mirror you are having a flat surface of water. Now, this is basically a mirror lens combination, and again the focal length should increase, and you have to higher up the pin and adjust the focal length. At the point of no parallax, you will get the remaining height, and from that you can calculate the refractive index of the water again. So, two experiment at one go. So, what are you waiting for? Don't miss out with this experiment. This is a calculation based experiment. So, you need to take 3 different trials for each reading, right, and each and every reading can be same, because obviously you are using the same lens and same water, right. So, reading can be same, but you have to take 3 different trials for each and every reading and calculate it. The refractive index of water will be around 1.5 or 1.33. So, make sure you are calculating it correctly. All the best for your upcoming practical exam.